This is question 29 from Statics LO4 tutorial sheet. So this is a question where we're given a number of facts about a material that's been under tensile stress. And from these facts, we're asked to determine Young's modulus. The units used throughout for this are millimeters for length, and when that's the case, there's no particular reason to convert. We're working with kilonewtons for the force that we're given, and again, we could be quite happy to work in kilonewtons for force here, but given that we sometimes have a bit of variation in terms of the size of our answer, it might be sensible to work in newtons for this question. However, consistently working in kilonewtons would not be incorrect. So let's have a look at what's going on here. We've been asked to find Young's modulus, and we know that Young's modulus is given to us. The only way we can find this is by dividing stress by strain. Furthermore, we know that stress comes from force divided by area, and strain comes from change in length divided by original length. And we actually have all of these pieces of information. We're told that the length of the bar is 250 millimeters. We're told that the cross-sectional area is 150 millimeters squared. We're told that the load, that's our force, is 25 kilonewtons. And as I've said, we're going to work in newtons for this part of the question. That's 25,000 newtons. And we're told the extension, that is the change in length, is equal to 0.2 millimeters. So we actually have everything we need. We'll keep all of our length units in millimeters and our force units in newtons. Let's first of all work out the direct stress. That's force divided by area, so that's 25,000 divided by 150. And that works out as 166.7 to one decimal place, or 4 significant figures. And our units are newtons per millimeter squared. So our forces in newtons and our areas in millimeters squared. The strain is equal to our change in length divided by our original length. Our change in length is 0.2. Our original length is 250. Both values have to be in the same units, and they are both in millimeters. Strain is, of course, unitless. Our answer, 0.2 divided by 250. Gives us an answer of 8 times 10 to the negative 4. We're expecting something relatively small for strain. And there are no units here, so don't try to give this units. It's millimeters divided by millimeters. The answer is unitless. So lastly, we can find Young's modulus. We have found the two things that we need, delta and epsilon, stress and strain. That will become 166.7 divided by 8 times 10 to the minus 4. Entering that into our calculator. Gives us the answer 208,375. The units for this are the same as the units for our delta, which are newtons per millimeter squared. And this is where we might be tempted to convert it back into kilonewtons, because this is the same as, rounded to 3 significant figures, 208 kilonewtons per millimeter squared. But the answer there would be acceptable in an assessment style question. So that answers question 29 from the LO4 tutorial sheet.